Now student, we will be demonstrating a practical, that is band gap of semiconductor by 4-probe method. Here is the setup. Now first I am pressing this switch. Now it is showing a digital display. It is the voltage. Now it is toggle switch. This side, left side, it shows current. Other side is the voltage. There is a variac. If you vary it, it will showing the variable voltage, and you vary on the current side, it will also vary the current. Always fix a current, and current must be as minimum as possible. You fix it, and then what you will do, move to the voltage side. Then it is a 4-probe setup having an oven. It's called circular oven or mantle. In this mantle is a metallic body. We are having a metallic disc, and here is semiconductor sample wafer, either germanium or silicon, and there are 4 probes connecting this vertically, and the gap is compared to the thickness. Gap is referred by S. That I will show you again, and how to operate. Now there is a thermometer. In thermometer, this is the scale where the reading can be judged. Initially it is showing around 22 degrees centigrade. Now this is the voltage showing. Now if I press it on and it is showing 1, that is out of range. So going to the 10, that is the multiply by 10, it is showing around 68, that is say 680, because it is multiplied by 10, so in millivolt. So while you press this another switch, oven switch, what will happen? Temperature will be slowly changing and corresponding voltage will be changing. So what we will have to do? There will be a periodical change of temperature. With respect to that, we will be noting the periodical change of voltage, keeping the constant current. So here, current is keeping constant, voltage is varying with the change of temperature to a certain extent, starting from the room temperature, whatever the condition is, and it will be up to 120 degree. Keeping in mind, it is working very well in the winter season compared to the summer season. Let us come to the board directly for more details. There is the wafer. Here are the 4 probes connected by a constant power supply, and this is the milliampere and the constant power supply. Here the current is supplying, entering and leaving the circuit, and here are the 4 probes. They are connected by a voltmeter, and between 2 and 3 there is a change of potential, and it is a wafer, that is germanium. It could be silicon also, but we are using germanium because its band gap is lower. The band gap of germanium, we know, that is only 0.7 electron volt, and for silicon it is 1 to 1.2 electron. Okay, now main thing you note, this is coming from the equation rho A is equal to E to the power Eg by 2 kT. Now let us see what are these. E is called the band gap, rho is called the resistivity, K is called the Boltzmann constant, and T is called absolute temperature. Now we note another thing. Whenever we heat it through a heating mantle, then what will happen? Because of heating, the lower surface will be heated, and between 2 and 3 the potential will be always changing. Keeping in mind, it is connected by the current source by the 2 ends, but between them the voltage, in order to avoid contact resistance problem. Now we have potential between 2 and 3 keeps on changing, generate floating potential, which will give rise to an exponential function, and this exponential function is defined by G7 W by S, and it is 2S by W ln 2, and the value can be also calculated 5.54. So in the after your observation, you have gotten value of rho by calculating rho, and the temperature you get by inverse temperature, you can get the graph looking like this, and this graph is looking like a just opposite inverted commas, lot of interrogations, and you take a linear part and get the slope. And after getting the slope, using the equation, what we will do, we will find the value of the band gap. Now, keeping in the mind that this is the main principal equation, and here we are ignoring rho naught. Eg is the band gap, and what is the last step we are doing? Determine the value of rho naught. Rho naught is V by I into 2 pi S. V is the voltage that we are applying. I is the constant current. S is the gap between them, and rho naught is a correction factor G7WS, because floating potential making a problematic. So every time it is changing with temperature, so it is restricted and being a constant value, so that only variable is voltage with respect to temperature. That is temperature, because of heating is changing, voltage is changing, so voltage temperature is plotted, and after plotting is completed, result is obtained and band gap is completed. And this is better method for other method, because we can determine resistivity as well as band gap. Thank you for your